Assalamualaikum and hi everyone. The topic is strain gauge. What is strain gauge sensor? When a force is applied to a solid object, there are two effects happen in the object. First, the object will be in stress, and also there will be deformation of the object. This deformation is what we call as strain. For example, when a force pulls a rod, the tensile stress is happen in the rod. At the same time, the length of the rod become longer and the cross-sectional area become smaller. These are the deformation happens in the rod due to the applied force. The same effect also happen when the rod is compressed, but instead of tensile stress, the term become compressional stress. The length becomes shorter and the cross-sectional area become wider. It means the strain value change when the different force applied on the object. From this example, we can see that the strain value change when a different force applied on the object. In this diagram, it shows that the strain gauges are used in measuring the deformation of the bridge. The force acting on the beam and the column is measured and the load is coming from the vehicles. So therefore, we can see that there are strain gauges measuring the deformation in the column and also in the beam. When the force is applied to a structure, the components of the structure change slightly in their dimension and said to be strained. Therefore, to measure these small changes, we use strain gauge. Normally, an electrical resistance strain gauge is used due to its simplicity, inexpensive, and reliability. In this figure, a lateral force is applied onto a supported beam. It causes the beam to bend. In order to measure a strain in the beam, we attach a strain gauge with length L. Due to the forces, the beam will become longer at the bottom and shorter at the top. Therefore, the strain gauge will also have a deformation of dl. From the deformation, we will be able to calculate the strain equal to delta L per L. A common value for a strain is in microstrain, and strain value is unitless, meaning there will be no unit for the strain. For example, a low-strength steel yields a strain of 1,400 microstrain, which is equivalent to 0.0014 strain. For elastic material, stress is only applied in single direction, and the stress value is related to the strain through the equation here, which is sigma equal to E strain. E is the modulus of elasticity or modulus Young. Therefore, for strain gauge, it only sensitive when the strain is happen in this direction. The deformation or strain happen in this direction is ignored because it cannot measure the deformation in sensitive direction. The strain gauge principle is depend on the change of electrical resistance that caused by stretching wire. So resistance can be calculated using R equal to rho L over A, where rho is the resistivity, L is the length of the wire, and area is the cross-sectional area, and R is the resistance value. Equation 1 can be differentiated logarithmically, where dr over R is equal to d rho over rho plus dl over L minus dA over A. So we can see here the change in resistance is depend on the change of resistivity plus the change of length, which is strain, and minus the change of cross-sectional area. So dl over L is the axial strain, and the area is equal to pi d squared over 4. Again, we differentiate logarithmically. We get dA over A is equal to 2dd over d, where it is transverse strain. We can relate between axial strain and transverse strain through a Poisson ratio using the equation here. Combination of all equation will give us the final equation where the change of resistance is depend on d rho over rho plus strain in axial plus 1 plus 2 Poisson ratio. So from this equation, we can see that the two component here, the first component and the second component, is a constant, because rho is depend on the material and the Poisson ratio is also depend on the material. When d rho over rho and 1 plus 2 V is a constant, we can see that the change in resistance is directly related to the change in the strain. So when strain is changed, the resistance also change. Common resistance strain gauge are made from metal foil with grid configuration. Metal strain gauge come in wide variety of sizes and shape. This is the shortest and longest length of strain gauge. The standard resistance change is around 120 ohm or 350 ohm. Because the strain gauge is made from foil, it is very fragile and easy to distort, wrinkle and tear. That's why we use a thin plastic film to serve as a backing. The resistivity and the Poisson ratio is combined and represented by gauge factor, where gauge factor is equal to delta R over strain, or delta R over R equal to gauge factor multiplied with strain. Gauge factor is representing the constant value from the equation. And gauge factor is given by the manufacturer. So for a metal strain gauge, the gauge factor can up to 6. Common value is around 2. A metal strain gauge are able to measure strain as high as 40,000 microstrain. However, there is also semiconductor strain gauge, normally used in pressure and acceleration transducer. The advantage of semiconductor strain gauge is that it has a high gauge factor than metal foil, which is 125 commonly. The disadvantages that the semiconductor material is not ductile and it's only measure low strain, which is around 3000 microstrain only. This list is a common alloy that use as a strain gauge. Okay, we can see here, this is tungsten, nichrome, and etc. So the strain gauge is around 2.1 up to 4. This is metal type of strain gauge. Example 1 is how to calculate the maximum resistance change in the gauge. So a strain gauge with resistance 120 ohm and gauge factor 2, the gauge is applied to a material with modulus Young 200 meganewton per meter and maximum stress of 50 newton per meter. So find the maximum resistance change for the gauge. Okay, so we know that the first equation that we have is stress is related to modulus Young strain. Then from there we can calculate change of resistance equal to gauge factor multiplied with strain. Okay, so we have the stress here, we have the modulus Young, then we can calculate the strain. Once we get the value of strain, we put into this equation, multiply with the gauge factor, then we get the change of resistance. So therefore, we calculate strain equal to maximum stress divided by modulus Young, which is 50 multiplied with 200 mega Newton per meter, which equal to 2.5 multiplied with to the power of 97. Okay. From the second equation, gauge factor equal to strain, or change of R equal to gauge factor multiplied with strain R. So from there, we get the change of strain equal to, from the calculation, we get change of resistance equal to 6 to the power of 10 minus 5 ohm.